if you now see my presentation in full screen. I think so. So good afternoon. Thank you, Cyprian, for the introduction. I'm really very happy to be here. My apologies if my voice is a bit fuzzy. I'm recovering from a cold my 2-year-old daughter brought in from kindergarten last week. So I hope you hear me all well enough. Sorry. Now, my name is Christos Makropoulos, indeed. I'm a professor of water management and hydroinformatics in the National Technical University of Athens. And I'm also a principal scientist in KWR, the Water Research Center of the Dutch drinking water companies. And what I will do today is I will present a very interesting, I think, innovation we have been developing and demonstrating in the city of Athens, and it's called sewer mining, whatever that may translate to in Romanian, but I will explain what it is. Now, before I get into that, I would like to give you some context on why sewer mining, what was the challenge we were trying to deal with in Athens. So the city of Athens operates a nursery, tree nursery, which supplies all the plants of the urban green parks and green spaces for the parks in Athens. So they irrigate a particular place, they grow the plants, and then they move them around town. And up to this project called NextGen, they had been irrigating the nursery with potable water, which is brought in literally from the other side of the country, so more than 250 kilometers away at great cost. And of course, the site, which is at the center of Athens, also had quite a few other things. Sorry, I don't know why this is happening. Quite a few other things. Pruning waste was accumulated from park maintenance activities. Organic waste was left on the site, and that is despite the fact, of course, the nursery as a site uses quite a lot of fertilizer. So essentially, before the project started, we had a very typical linear resource consumption situation, like Anne was talking about, for water, I'm not sure why this is happening, my apologies for this, a linear consumption model for water, for energy, and for materials. Now, solving each of these problems separately is quite a challenge, but with NextGen, we decided to solve all these three problems at the same time, as it were, following a circular economy approach. So what we did is we installed a sewer mining unit. Essentially, this is a treatment plant in a container, which we developed initially as a proof of concept within a previous European project called DESN. And through this mobile, essentially, a small compact mobile treatment unit, we are able to mine wastewater from the sewers that run under the nursery. Actually, they run under every part of every city, and provide high quality, reused, treated water at the point of demand. Now, we also, in this case, added a thermal recovery solution so that heat exchangers and heat pumps that benefit from constantly high temperature of raw sewage can be utilized. And we also decided to use the organic waste from the prunings that were already available, together with the sludge from the sewer mining unit, to produce compost. And this is a diagram, a pretty busy diagram, I would say, of how everything fits together. And now the blue lines are the water cycle, which are more or less what I discussed. Green is the material cycle, in this case, the compost, and red is the energy, let's say the heat cycle. So you can see here to the lower left, the sewer mining unit as it stands currently on site. So there are two containers actually. The container to the right is the treatment plant. Let's say the container to the left is the control room. And the unit consists of essentially a membrane bioreactor unit and a UV disinfection unit, which produce very high quality reclaimed water for irrigation and of course also for aquifer recharge during winter. It's a very stable and efficient solution, very small footprint, and completely negates the need for expensive water transportation systems, which often become a barrier when we want to reuse treated wastewater from wastewater treatment plants. Wastewater treatment plants are, of course, at the other side of town usually, and this makes it very hard to get the treated water back to the center of the city. Now, a simple process diagram can be seen here, and this is the unit. Sorry, this is the unit, the MBR UV unit, and it's fully operational now in the city of Athens since April 2021. Now we have also implemented a rather sophisticated control system, fully automated, which uses remote actuated valves, controlled of course by PLCs, and we also sample at 5 points and analyze the parameters to make sure that we comply with regulations. And an interesting thing that we worked on and developed as part of the project was the way to couple this unit to a sewer. So together with the Water Company of Athens, we developed a solution, let's say a custom pumping station solution, which is now, let's say, a blueprint for placing similar units elsewhere in the city, elsewhere in any city really. So it did take some work to be able to mine it. So you have the unit on the surface, you have the sewer underneath, you have a manhole, and you insert essentially a pumping station, a particular type of pumping station, which is easy enough, but of course we had to do it to make it work. So we now have a blueprint for that. Now, what about quality? Does it work? This table presents aggregated results of quality characteristics of the effluents along with the limits. Now, these are limits set for water reuse by the Greek national legislation. So you can see that they all lie within the limits for unrestricted irrigation and urban use. And this, of course, very important for upscaling, for transferability, for everything. And here you can see UV disinfection and how it performs. It performs very well indeed. And actually the elimination of organic carbon and pathogen content is complete. And part, let's say, the solution is filtration, managing to reduce pathogens without adding chemicals, and as such avoiding the production of secondary pollutants. I think this is also a very important part. Now, as I said, above the or together with the sewer mining unit, looking at the water cycle, we also installed the rapid composting technology, which uses excess sludge produced by the sewer mining unit together with additional bio waste, in this case green waste, from the prunings of the parks to produce on-site fertilizer, which is of course also applied to the nursery. Now, just note that this is not necessary in principle. So you can use a sewer mining unit without treating sludge on site. Perhaps you can't. Perhaps it's a small place or a downtown place, a small park that you can't treat in any way, shape or form sludge on site. In that case, the original design of the sewer mining unit is that you can throw essentially the sludge back into the sewer to be transported through the flow to the treatment plant. And there are a few considerations of that I will explain later, but of course that makes it more flexible because it means that you can use a sewer mining unit almost everywhere. This compost unit that I was talking about is also remote controlled, remote monitored, which is of course key if you plan to operate multiple units throughout the city. Now, finally, in terms of energy recovery, we are now installing a heat exchanger, heat pump system. As you know, there is a constant temperature of sewage water, irrespective of conditions, environmental conditions, around 15 to 20 degrees. And of course, this is a gradient that a heat pump can exploit. So this covers water, energy, and materials. Of course, again, as I said, sewer mining can happen individually. Now, we also use this pilot, these technologies, irrigating the tree nursery, to also develop and test several tools, including QMRA, a quantitative microbial risk assessment. Of course, it's an important part, both for the effluent and the compost. The QMRA tool is actually a watershed tool. Since watershed is co-sponsoring this, I should highlight this. And we also developed tools to help us redesign and then stress test water supply systems that include, for example, sewer mining units, using a model called UWAT. And UWAT is also a watershed tool. Now, of course, there is no time to get into details of what UWAT is about, but here's a screenshot of the interface of UWAT, drag and drop type of environment, where you can place components of the urban water cycle. You can set up, simulate, and explore trade-offs between centralized and decentralized water infrastructures at multiple scales, from the household all the way to the city. And of course, this means that you can check, and design for transferability and upscaling. Now, this is an example of what the sewer mining configuration looks like in UWAT. And of course, you can use this to test scenarios of both demand and supply changes, and of course, climate change as well. Now, we also developed a tool to help us identify suitable locations within a sewer system to install the sewer mining unit. And what this tool does, so of course, in this case, we had a particular location, the tree nursery, but in principle, the sewer mining unit could be placed anywhere in the city to irrigate parks. So the tools allows you to import the network topology, the sewage network topology, and the manholes and everything, hydraulic characteristics, diameters of the pipe, slopes and stuff, land uses, to identify areas that would benefit from sewer mining, so parks and things like that, and any other spatial data. And then it runs a Monte Carlo simulation using SWIM in the background, the simulation model, to identify suitable locations that achieve two things. The first is they are suitable from a demand perspective. So nodes are close enough to green areas so that it's efficient to irrigate them through that part of the network. And there is, let's say, a risk minimization. And the risk is, of course, not in this case, but if you remember, I said that if you decide to not to treat the remains, let's say the loose sludge there, then you can pour it back in the sewer. Now that is fine, of course, in most of the cases, but you have to take care that you don't produce sulfuric acid in the pipes, and this is related to let's say the hydraulic properties of the network, and the tool allows you to actually do this. So identify the best locations in the network. It handles sewer flows probabilistically linked to water demands, again probabilistically. So it identifies the optimal places in a very sophisticated way, I think. So last slide. To conclude, I hope that I have provided you with some, let's say, food for thought and some evidence that sewer mining is a really very interesting circular economy technology that provides, if you like, climate-proofed non-potable water. For example, water you need for irrigating green spaces in dense urban environments. And of course, this is since it links to wastewater, it becomes independent of the natural water cycle. You can always do this irrespective of water conditions. We have extended this technology in this particular project and used it as a basis to also close material cycles and energy cycles at a very local level. And we created this real world demo. So it's not a lab thing. You can see it to the right, the final look, let's say, of the site, very minimal footprint. It's a real site in that this is the intended use. The city of Athens is the intended end user. Of course, the fact that it is the city of Athens has significant, let's say, PR value, if you like, for transferring this to other cities around Greece, but also elsewhere. We are working with the company of Athens towards a plan of their own, to deploy this technology in multiple locations in the region of Attica to meet their reuse and climate adaptation goals. And actually, interestingly enough, together with our French partners in NextGen, we're having an interesting conversation with the French market, which also seems to make all the right noises, seems interested. Actually, we had an expression of interest from Euro Disney for this. I really haven't felt so excited about a Disney initiative since I was a child. So I think that's interesting. I think the idea and technology is ready for a much wider uptake. I would very much like to work with people from this audience to see potential applications elsewhere, for example, in Romania, but also elsewhere. So thank you very much. Thank you very much for the attention.
Thank you. Thank you very much, Christos. You probably know that Timișoara Aqua Team, which is the water utility in Timișoara, is part of the NextGen project. And from my point of view, I'm trying to develop their expertise and maybe to create even a stronger business case in Timișoara. But also, it's a question of social acceptance. I found quite resistant the public company which is taking care about the parks, watering the parks. They don't know too much about what is the meaning of water reuse and using that water that can be delivered from the utility in Timișoara. But we work on that, and I'm positive. But I'm now in a hurry. Thank you very much, Christos, once again. I'm in a hurry to send the ball to our colleagues from Israel with another interesting